Well, hey everyone. Welcome back today as we continue to work along this concept of coordinates. Today we're going to be kind of talking about where these come together in terms of like word problems or story problems, word or story problems, and this idea of just kind of like, real world application of like why this works and what we're doing with it and why it's important. We've already gone down that line. I have to review because I can't help myself of the idea that, again, as mathematicians, we've taken this thing called a plane, this like surface we can't really see, and we've created a coordinate to help us kind of like see things that are invisible. And these coordinates are done on, oh, I keep doing that. I'm gonna get that down. X and Y coordinates, right? And they're just there to help us pinpoint and measure the location of things. And we do that again through something called an ordered pair, meaning there's two pieces to it, X and Y, and that we always do it in the same order, which would be X, then Y. So again, if I had, a number line that stretches on this way forever and reminding us that this is the origin, right? 0, 0, it's where it all starts. So this would be 1, 2, 3, 4, 5, 6, 7, 8. And up here, in our Y, we might see 1, 2, 3, 4, 5. Again, these going on infinitely. That's why there's an arrow pointing there. But again, let's say right here was point C, right? So my ordered pair for C would be X first, which you can see lines up with 3. So my ordered pair for C would be 3. And then we look at the Y. See, it matches up with 3 again. So I have this ordered pair of 3, 3 for the coordinate of C. Its ordered pair is 3, 3, 3x, 3y. And then what we kind of started talking about from there, and this is why we are reviewing this, because this will start to make some sense, is, if we had a point D here, we're starting to look at, well, what's this distance between the 2 points, right? How many units are we traveling? And when we talk about those units, one of the things we had said that is helpful is that we know that these lines are these infinite lines that go on forever. They're invisible, but if we can draw them in to make sense of them, right? This is the 2 going across. And so if I focus on what I do when I kind of connect all that, you can see I've actually made an array of rows and columns, and I can actually count. Well, if I'm here and I go here, well, I'm moving 1, 2, 3 units. And in this case, those units are just a square. So square units is something that we could say. But also like a unit could mean that maybe this is 1 mile, like each square is a mile. So C is my house and D is the school. So the distance between the 2 is 3 miles because it's 3 units and each unit equals a mile. And that's what we're going to talk about today, is reviewing on the last 2 things we've talked about. A, the coordinates and what they are in a grid and ordered pairs. And then B, when we have lots of different ordered pairs on a coordinate, then what are the distances between them, or how do we solve certain story problems to make sense of that? So I'm going to go ahead and take this, and we're going to start up with another coordinate. I'm going to try to make this one fairly large so we can use some bigger numbers, I suppose. And again, this is going to, I did it again, y'all. This is going to be X. So here's my origin of 0, 0. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3, 4, 5, 6, 7. So I'm going to go back to an ordered pair over here so we can remember all of our steps, meaning that we always go X and then Y. And then, oh, I guess I should probably check marks. That would make sense. So 8, 9, 10, 11, 12, and then with our y-axis, which I did not label, we have 1, 2, 3, 4, 5, 6, 7. And then I'm going to go ahead and just put on some ordered pairs of coordinates on here. So let's see, I'm going to go here. We're going to call this one A. I'm going to call this one B. Maybe we'll go call this C. And let's go right here. We're going to call D. Okay. So one thing now that we're noticing is our coordinates are actually all over the place. None of them are on the same vertical x-axis or on a linear y-axis, right? They're not on the same line. So again, I could think about if I drew out these lines and they go on visible lines and I want to draw them so I can see them, that's fine. Right? We see they're on a certain one, they're on a certain coordinate, but they're not all on the same one. So they all don't share something. But by doing that, I can also come across this way. You know what? Instead of dapping, I'm gonna feel like that's probably making noise on the microphone. That sounds weird. So we'll draw some lines here. But again, what we're doing is we're making a big grid, right? We're making a big array. We have rows and columns now, if I kind of do this. And then we kind of run through these scenarios where it's like, okay, well, let's just say, oh man, I didn't get myself, I might gotta go another page right now. Let's just say we want to find that distance from A to B, right? So let's say that that's the piece that we need to do here. So if we go back there and we start on A, we have to think about what does it take to get to B. So remember, our ordered pair does work around X and then Y. So what I'm actually going to do is I'm going to go on this adventure, travel, just like you would if you were walking down the street. And I'm going to travel first by X. And I'm going to think about how many units it's going to take me to get from A to B. So if I start here, I go here, there's 1 unit, right? 2, 3, 4. So what I did for starters to get there is I moved 4 units to the right. And then we got to think about, well, how do we now get up? So I follow my Y, and there would be 1, 2, 3, meaning I would need 3 units up. So that would explain how I would get there. That would be the total of 7 units that I had to travel. And again, we could look at that 1, 2, 3, 4, 5, 6, 7. But it's really important that we kind of talk about it almost like a treasure map. Like first, right, move 4 units to your right. So 1, 2, 3, 4. And then move 5 units, or excuse me, 5. Wow, wrong page. 3 units up, 1, 2, 3, and that's how we would get there. Right? So then we could continue to play this game, and then someone says, all right, cool. Well, what is it going to take for you to travel? Let's say the distance. How do we find the distance? How do we follow this route from B to D? So if we go back and look, we're like, okay, well, here's B, this is where I am on B, and I need to get to D. And the first thing I need to do is follow my X. So I'm going to move left and right. So I'm going to go 1, 2, 3, 4, 5, 6, 7 units to the left. So we first started with 7 units to the left. And then we're going to do our Y. And you can see here, we're just going to go 1 unit down. So then we go 1 unit down. And that's how we would get there. And that's all this work is it's like following a map. It's this treasure hunt. So let's just like quickly look at one more quick scenario. And then that's really going to be it for us as we think about this process. And then we'll practice this skill out in class. So let's go ahead and build a new coordinate. And maybe I'll make this one a little bit smaller for the sake of time. So our, oh boy, let's try that again. Our Y would be 1, 2, 3, 4, 5, 6. Let's just say that. Can't forget our origin, 0, 0. where these two start. And then my X would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. Sometimes people ask, and we're actually asking today in class when we were working on this, is like, why is X always longer? I think that's just your paper has more space. They don't have to be, they're infinite. They go on forever. So just know it's whatever you fit in, but make sure you make good increments so you can see them. And sometimes they tell you how far you have to go, so you'll know what to do. Okay, so then let's just put out some points here. But this time, instead of points, I'm going to have this represent something. So like maybe this right here is going to represent my house. Let's say this one right here represents the school. So H for house, S for school. Let's see, I have something right here, which is the tree. This is the park. And then maybe we have one more right here. And this is the, I don't know, the corner store, right? What's that gonna look like? I guess just like this. It's my corner store. So the store is where I'm gonna go get my chips. Okay, so again, you would have a scenario like this, and that's talking constantly about like, what are the routes you would take? So in this case, maybe a question is like, well, what is the distance, right? What's our distance from your house to school? Well, I'm starting at the house and I have to think about how I'm going to travel to the school. Well, I could create my whole grid, right? We could draw those grids in like this, and that is super helpful, right? I could definitely do that. But I also have the ability to think about numbers and units like we did before, and realizing that here, if I look, I see I'm at 2. I'm gonna have to go up to 3, then go up to 4, and then go up right here to 5, right? That's where we would be in the equal. So I can see here that I just went up 1, 2, 3 units. So we go up 3 units. And then from there, I would have to travel back. So we're at 7 and we're going to 3, right? That's what I'd have to do. I'd have to travel right back here. And we can see that that would actually just be 1, 2, 3, 4 units, or 7 minus 3 is 4. So we're going to go up 3, and then we're going to go left, right? Remember, not back. I guess I did say that. The reality is we're moving left on our coordinate. We're going to go left 4 units. And that's how we would get there. And so then it would be like, well, then let's say each unit equals, wow, it's not, there you go, 1 mile. So the question would be like, how many miles does it take me to get to school? Well, if I walk 3 miles up and then 4 miles to the left, it's going to take me 7 miles to get there. And then maybe the next question says, great, it's 7 miles to get to school, and then you walk home the same way. How many miles do you walk every day? Well, that would be 7 plus 7 is 14. Or there could be other scenarios, like you start at your house and you travel to the park and you play. And then from the park, you're like, oh man, I'm really thirsty. Time to go to the store. Well, you would be tracking that. Oh, and then you have to go back home. How about that? So then you would be tracking how many units you're traveling the entire time. Think about how long you travel to do that. And then you would find each unit and put that together, which I guess I just did there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 units to do that whole thing. So that's really what we're going to be working on. As always, just a brief introduction. The real work is done on in class, but if you have questions, as always, we're always asking. That is part of our math norm. And as always, we appreciate your time, and we'll see you at the next video.